Hello everyone, welcome back to the channel. This is teacher Jeremiah and welcome back to the SMO Unlocked step-by-step solution series. Today we're going to look at a question, a very interesting one, finding invariants in dynamic problems. Let's look at the question. So this question, triangle ABC is a triangle resting on perpendicular sides MON as shown below. If triangle ABC can be rotated such that point A lies on MO and point B lies on ON, what is the greatest value of OC? So this question, quite interesting. We see that as long as points A and B lie on their respective lines, we want to find the longest greatest value of OC. So to find the longest value of OC, we can rotate this figure ABC. And let's see how we can rotate it. If I rotate it vertically, right, if AB becomes vertical, then it will look something like this. And this is the length of OC. And also, we can make AB such that it is horizontal. And if it's horizontal, then it will look like this. So we can see that the length of OC is changing. So when we come to this kind of dynamic problems, how do we solve it? Oh, it looks so hard. Looks like there's almost infinite possibilities where the length of OC can be. So to be able to find the length and the greatest length of OC, first we have to understand that for these kind of dynamic problems, the trick is to find some things that are fixed or known as invariants. So we have a look at some of the invariants today. And let's start off with one of them, which is in this figure, we are dealing with a right angle triangle ABC. Before we start off with a triangle, actually we have to start off with a rectangle. Let's have a look at this rectangle, and you can see that the diagonals of the lines are also drawn of this rectangle. And can you tell me, what do I know about the lengths of AC and BD, these diagonals? Oh, you might have noticed that, and remember that the lengths are the same. The lengths are the same. And now, if I cut this rectangle in half, and if you can see that we get a right angle triangle, what can I say about the length of BO now with respect to AC? Oh, you might have noticed, because we cut this in half, so BO will be half of the previous BD. And we can see the length of AO, OC, and BO, they are equal. They are equal. And now we know they are equal. Let's test if we know how to apply the knowledge. If I have AC is 8, then what would the length of BO be? Yes, it will be 4. Perfect. So now, let's move on to the next part. And let's summarize quickly that once we have a right angle triangle, BO will be half of AC. Now, on to the next point, which is if I have another right angle triangle, and this time, I mark out the lengths of these triangles. Length A, length B, length C. What do I know? What's the relationship here? Oh, if you've learned before or if you watched the previous video, you will know that we can use the Pythagoras theorem. A squared plus B squared equals to C squared to calculate the areas of this triangle. And now we move on to the last final knowledge that we need for this question. If I have a triangle ABC, this time I never say it's a right angle, right? Any triangle ABC. What can I say about the relation between the length of C and length of A and B, the sum of A and B? Oh, some of you will say, I don't know what is length, but we can conclude something. Right? Which one is longer? You will see that C will be shorter than A plus B. Length of C will be shorter than A plus B. Now, if I start to squash this triangle now to this, is it still true? Oh, looks like it is still true. C is still less than A and B. But now, in a very extreme case, if I squash it even more until they all lie on a single line, you will see that this time C is equals to A and B. So no matter what, whenever I have a triangle, I can have one conclusion, which is C will be less than or equal to A plus B. Now with this knowledge, we can apply to the question. So now that we know this invariants, let's have a look. I want to find the greatest or the longest length of OC. And it can be changed. So, because it's a dynamic problem, I need to use some invariants. And can we apply some of the invariants we learned? First, we have to go from OC. Looks like we have to pass through AB. And anything that we know, yes. the first knowledge that we learn. First, we have to go through AB. And actually, AB, the midpoint is, let's call it point P. If we go from O to P, what will the length be? If the length of AB is 8, OP will be 4. Okay, and now all we have to do is go from P to C. So let's draw a line P to C. Can I find the length of PC? You might notice that APC is a right angle triangle. So here, you can see that I can use Pythagoras theorem. First, we need to have the length of AP. What's the length of AP? Oh, it's half of AB will be 4. Yes. So we can see Pythagoras theorem says AC squared plus AP squared gives us CP squared. So I will just apply that. CP squared is equals to 3 squared plus 4 squared equals to 25. And CP, length of CP will just be 5. Now that we know the length of OP is 4 and CP is 5, you can see we want to find OC. And this is one of the triangles we have here. So what can I say about the length of OC and the length of OP plus PC? Oh, this is the third thing that we have applied, which is that OC will be less than or equal to 4 plus 5. So the greatest possible length will just be 4 plus 5 equals to 9. And we have solved this question. So let's summarize what we've learned. Firstly, if I have a dynamic problem, these kind of values, they are always changing. I need to find some things that are fixed, known as invariants. And some invariants that we've learned today is if we have a right angle triangle ABC here, then BO will be half of AC. And next, if we have another right angle triangle, this time having the lengths, that to find the length of the longer side, I can use A squared plus B squared equals to C squared, Pythagoras theorem. And last but not least, if we have a triangle, what can I say about the length of the longer side and the sum of the two other sides? It will be C is less than or equal to A plus B. And we've successfully summarized this question. Now, let's have a look at one of the practice questions. So, you can try out this question and you can leave your answer in the comment section, or you can also share with us your answer in our WhatsApp chat group here. If you have any other questions, you can also feel free to reach out to us or scan the QR codes and contact me directly as well. And next but not least, subscribe to our channel. Click the button below right now for more updates on more interesting e-learning videos. If not, let's have a look at last week's question. That is last week's practice question, and the answer is 289 units. Did you get it correct? If you have, share with us your workings in the group. If not, you can also ask us any questions. I'll see you next time. Bye-bye.